Welcome back to The Explainer. Today, we're going to pull back the curtain on something that pretty much powers our entire digital world. It's this hidden force you rely on every single time you click, tap, or stream. We're talking about cybersecurity availability. So let's dive right in.
You ever stop and think about it? How is it that your favorite streaming service is always there for your next binge watch? Or how your banking app lets you check your balance at 3 in the morning, no problem? It kind of feels like magic, right? How do these incredibly complex systems just work all the time?
Well, it's not magic, not really. The secret behind that seamless, always-on experience is a core principle in cybersecurity called availability, and it's one of the absolute cornerstones holding up our entire digital world.
I mean, let's face it, we live in an always-on world now. We've kind of lost our patience for waiting. We expect every single digital service to be there instantly, the second we need it. And that whole expectation, it's built on this one principle of availability.
Okay, so what is availability? When we talk about cybersecurity, what does that word actually mean in this context? Let's break down the official definition.
To put it simply, availability is the guarantee that all the information, all the systems, and all the resources are there when you need them. But, and this part is absolutely key, they have to be accessible to authorized users. It's all about making sure the right people have access at the right time, every time.
And if we break that down even more, you'll see availability isn't just one thing. You got to think of it as a bunch of different things all working together. You've got to make sure access is locked down to only authorized people. You have to keep the physical hardware running. The operating systems have to be working perfectly, and you have to prevent any digital traffic jams or bottlenecks.
And believe me, the stakes for getting this right are huge. For a big e-commerce company, just a single minute of downtime can cost them tens of thousands of dollars. So how do they do it? Well, it's definitely not a set it and forget it kind of thing. Keeping things available takes constant, proactive work happening behind the scenes 24/7.
So this behind-the-scenes work usually boils down to 3 big jobs. First, constantly taking care of the physical hardware and the operating systems. Second, applying all the important system upgrades to patch any security holes. And third, making sure there's more than enough bandwidth to handle all the users without things slowing to a crawl.
So you do all that maintenance, and you've built this amazing, super reliable system. But what happens when someone intentionally tries to tear it all down? Even the best digital highway has to defend against an attack designed to cause total gridlock. And when we're talking about availability, there's one main villain, the distributed denial of service attack, or DDoS for short. On the left side here, you see how things are supposed to work, real users getting to the service they want. But on the right, that's a DDoS attack. It's just a massive, overwhelming flood of traffic. Think of it like this. 1,000 people who have no intention of buying anything suddenly show up and block the entrance to your favorite store. That's a DDoS attack. It's a digital traffic jam created on purpose to keep real customers out.
So yeah, the official definition is that a DDoS attack is a malicious attempt to mess up the normal flow of traffic to a server or a network. The goal usually isn't even to steal data. It's just to cause chaos by shutting a service down, making it unavailable for everyone.
So if these attacks are a constant threat, what can you do? How do companies fight back? Well, they build what you could call a digital safety net, a whole collection of strategies and tech designed for when things inevitably go wrong. This safety net has a few really important layers. First up, you've got redundancy. This is basically having a spare tire for your server, extra parts ready to jump in the second something fails. Next, you have backups. This one's pretty straightforward. It's just making copies of your data and storing them somewhere safe in case the original gets lost. And finally, there's disaster recovery. This is the big one. It's the master plan for exactly how to respond and get back online after a major problem hits.
And beyond those basics, there are some even more high-tech methods being used. For instance, failover systems can automatically switch to a backup server if the main one goes down. You've got RAID technology, which protects data by spreading it out across a bunch of different hard drives. And then you have high-availability clusters, which link servers together so if one fails, the others just pick up the slack instantly. The whole idea is to have no single point of failure.
So, when you boil it all down, what's the big takeaway here? It's this. That seamless, always-on experience we all just expect now, it's not an accident. It is the result of a massive, continuous, and very intentional cybersecurity effort that's all focused on one thing, maintaining availability. And this all leaves us with one last, pretty heavy question.
As our society relies more and more on this instant digital access for literally everything, from our power grids to our healthcare, what is the real-world cost when availability fails?